We are going to use the StS Co case in our Go programming lecture in week 10. Therefore, I make this video to explain the general formulations we need to use in the lecture. So first, let's see what's the problem. So the case is about a small Danish company. They do laundry service for restaurants. Currently, this company faces to a supply chain redesign problem because they signed the new customers, so they would like to expand their business. So now you can see this is the market situation. So the right places are the restaurants the company needs to serve, and the green places are the potential facility locations that they can build new facilities. So they have the target to provide excellent service to this 20 Michelin restaurants. So in this map, we can also see in this area in Copenhagen, so the many restaurants located in this area. So the decision is where they should build this facility in order to deliver the service with a short time and low driving distances. Furthermore, in the documents we provide, so this is a StS data Excel file. You can find the further information about this case. So we have, for example, the addresses for the potential facility locations. So here you can see we have 5 potential facility locations with addresses, and in this column you can see we have 20 Michelin restaurants to serve. So now let's further look into the pre-known information about this case. So the next step, we try to first we define the potential. So I use a network map to show the first information about the potential facility locations and the customer restaurants locations. So now you can see we use an index I, small I, to indicate the potential facility sites. So we use a set capital I to denote the facility locations, and we use small g to show each restaurant. So we can see Michelin restaurant G means individual restaurants. Then we use a set capital G to denote all the restaurants. So in the following formulations and analysis, we always use I to represent the potential facility locations, and a small g to show the restaurants. So in this map, we can see each facility. If the company builds a new facility, each facility can serve multiple restaurants. So, for example, the Housens, if we build a facility, they could actually serve the customer, for example, but of course they can also serve other restaurants. So there is a decision to make for this company. It's called assignment. So how to assign the restaurants to the facilities. So that's the first decision. Next, if we look into an individual restaurant, for example here, the restaurant MR4, you can see this restaurant can also be served by multiple facilities, for example, SF4 and SF5. So here the question is, what's where or which facility should be built or to establish? So that's the two questions we need to answer this problem. Before we can formulate this problem, we need to always start by step 1, identify the parameters. So we can always write step 1. So identify the parameters or get to know the data. So we use a series of notations actually to represent all these parameters. Then we can easily use them in the formulation later. Here in the documents of the case, so you can actually download the case text from Blackboard. It's called StS Co case. So from the case text in the page 2, you can get the initial data about these potential facilities. So for example, in this page, we can see for each facility I, we know the investment costs. So here, if we use a notation Fi to represent the investment cost for each facility, for example, F1 equals to 6.9 million Danish kroner. So this investment cost for Horsens, for the Horsens facility. Of course, you can continue to interpret this data. And in second column, this column, so we can find the operating cost per month for this case. So we use a notation theta I to show a monthly operating cost for each facility. It's like a fixed operating cost, maintenance or utility cost, and so on. So this is theta I, for example, theta 1 equals to 450,000 Danish kroner per month. And the last column here, we can see we have a capacity in pallets for each facility. So we use a small si to represent the capacity for each facility. So S1 equals to 16, S2 equals to 18, and so on. So that's a first set of the parameter or the data we should know about. We will use these notations later in the formulation. So that's about the potential facility set. Furthermore, we can see we actually also have a series of data from the data source you have. So again, this data is from the Excel file STS data. So in this file, we can see the first set of information or the data we have is travel distance, so in kilometers. So let's interpret this data. So first, let's see, here is a facility locations. So here is a potential restaurants, and if we serve the customer from one location to one restaurant, then the particularly driving distances are given in this table. So if we define the travel distance as a small l, and from facility I to restaurant G, then LIG data is available in this table. So this is a travel distance. Similarly, we have the travel times for each pair of the facility and the restaurant. Here we define the travel time as a small t from I to G, and the data is available here. For example, from Howson's restaurant, from the Howson's facility to the Copenhagen Pierre Henrik Alley. So this restaurant, the travel time is 167 minutes. So all this data units is minutes. So that's about the travel time and the travel distance. Furthermore, in this table, you can also find further information about the costs. So here we have the service costs from service facility I to restaurant G. We can define the service cost small g, RLC from I to G, and this cost is the total cost for serve all the demand from one restaurant. So in that sense, if you only serve part of the customers from each restaurant, part of demand from each restaurant, then this CIG should divide it by the proportion of the demand. And here we can also see one more set of data is make it a little bit bigger. So let's see. Here we have demand information. So this demand is related to the individual restaurants. So the restaurants are different, so they have different number of tablecloths to be washed. So we use a letter notation DG to describe the demand for each restaurant. So here G belong to in the set of capital G. So here the last section of this table is a repetition of the cost information we described before. So here we do not repeat it. So I put this table, put these two tables together so that you can find the notations about. Put this up, so put this down. It's probably better now. So that's how we define all these parameters, identified all these parameters. So in summary, I use handouts results from our teaching lecture handouts or PowerPoint slides. So you can see here is the parameters we needed to use or we identified from this case. You can find the detailed data from the Excel data. I do not repeat this. So after we identified all these parameters, now we can think about the decision variables. So if you still remember, we have I, potential facility sites or locations. Then we have 20, so 5, so it's 20 restaurants, Michelin, Michelin restaurants. So now, next step, we transform the decisions into the decision variables. So the first decision is we're not necessary to build all the 5 facilities, so you can choose to build some of them. So the first question would be, so the first decision variable will be where to build or to establish a facility. Then we use a decision variable y, I, so to denote the decisions. So the decisions will be built or not built. So in mathematics, the value would be 1 and 0. So of course, if you establish, then you have the yi equals to 1. Otherwise, if not establish, then yi equals to 0. So that's a first decision variable. So this decision variable, you probably have seen it in the integral programming lectures. So we call it binary variables. So binary variables. So you have only value 0 or 1. Sometimes we also call it indicator variables. So the second variable is how to assign related to how to assign the customers or the restaurants or the demand to the facilities. How to assign restaurants or customers or demand to facility. So the relationship is about from I to G. So we define a decision variable xig, so which is the percentage of demand in restaurant G to be served, to be serviced by facility I. So here we can see this value is a percentage. So xig should be in the range of 0 to 1. So for example, so we have a facility 1 serves 50% of the demand from restaurant G3. So then you have x13 equals to 0.5. So that's how we define. Of course, before you make a decision, we need to consider all the pairs from I to G. So you basically have 5 times 20 variables. So total we have 5 times 20 x variables. And we have here 5 binary variables. So that's the decision variables we need before we introduce Go programming. So after we got the decision, now we are ready to construct the objective functions. So first, the objective function is related to the 4 goals specified in the case. So let's see, here are the 4 goals. First, we construct the functions or formulations for each goal. So here we start by the first goal, the total investment cost. So the total investment cost, we use a notation capital X, capital IY, actually, should just. So capital IY to denote the total investment cost. Then this cost only related to each individual facility, potential facility investment cost. So we know the investment cost for each facility times decision variable, then this would be the total investment cost. So for example, if yi equals to 1, then fi yi equals to 1. If yi equals to 0, then yi equals to 0. So that's why we need this binary variable. So the second objective function is monthly cost. The monthly cost including two parts. So first we define the notation for monthly cost, capital C x, y, including the monthly operating costs plus service cost. So the monthly operating cost, we know the parameter for individual facility is theta I. Then the decision variable for facility establishment is yi. So the total monthly operating costs depend on how many facilities the company will build. And the service cost, individual service cost is CIG for total demand of each restaurant, and the times percentage allocated to each facility. Then we time them all these restaurants' demands together. Then we got the operating cost for each facility. So we can see here also for the entire company, if we build multiple facilities, then we should also sum up the operating cost across different facilities. So that's how we got the total monthly cost. And then the third is average traveling time. Average travel time, here the average means the travel time from each facility to each customer. So this average should be divided by the total number of restaurants. So first let's see, we use a notation capital T x to denote the average travel time. And we first calculate the total traveling time among each pair of facility and restaurants. So the individual travel time from I to G is TIG, and the allocated demand XIG shows the average travel requirements. And this is the total travel time for in this company. Then it should be divided by total number of customers. So then this is a general performance evaluation for the for each customer. So it's average service time to each customer. So the fourth one is average travel distance. Is similar like average travel time. So we use the average travel distance among all the facilities and customers. So we have a travel distance, Li divided by the demand. So that's how we formulate the objective functions. Here, we, for the time being, ignore the goals of the quantities. We just use these formulations as the description of the objective functions. You can also think about you want to minimize all these costs. After we introduce the Go programming, we'll integrate with all these different goals. now we can formulate the constraints. So now let's see, we borrow the network diagram again. So let's see, this is the service and customer relationships description. So here we can see each facility can serve multiple customers. But when we assign the customers to or demand to the facilities, we have to consider the constraint of capacity. So here we consider the first constraint is a capacity constraint of facility I. Here we have a facility capacity parameter Si, and we have a decision variable of Yi if you build or not build the facility. This is a capacity, and the consumption for your services actually is over multiple customers. Then total demand for each customer is DG, and the percentage allocated to each facility is XIG. So this actually is the total service allocated to facility I. So this should be less than or equals to the capacity Si times Yi. So here, of course, for all the potential facilities. So this is a capacity constraint. The second, we can also see from this diagram, one customer can be assigned partially to one facility. So if your customer is allocated to different facilities, then you still need to remember all the demands should be satisfied. So here we have a constraint of the total. Continue blue. So the total demands allocated to different facilities from one restaurant is XIG. So should all be satisfied. So this should be 1. So the total demand should be allocated, of course, for all the restaurants. So that's constraints. So we actually have a third constraint is a general constraint for unconstrained variables. So we always have a non-negativity constraint. So here we see XIG should always be greater or equals to 0. Of course, for all I and G. And the decision variable, so I do not have space, I put them here. So the fourth one, the fourth constraint actually is the binary variable constraint. So we actually already mentioned them and we define the decision variables, but here we just repeat the decision variable Yi should always be 1 or 0. So for all I. So these are the 4 constraints. After we have all these 4 steps, now we can summarize the formulations. So here, the first part is the objectives. So here, there are different constraints. So there are 4 constraints, there are 4 objectives. It's not important for us now to see, okay, I have these constraints like objectives. So we can ignore the constraint for the time being. You just know the company needs to make decisions based on the different objectives regarding cost, traveling time, traveling different distances. So this actually lead to a multiple objective mixed integer programming model. In order to solve this problem, we need a methodology. So in the lecture in week 10, we will introduce the Go programming method. So if we say we have done, all the formulations, next step would be to put all these formulations into Excel solver setting up. So then we can actually introduce you a solution method, how to solve the Go programming model in the class. So this Excel file, actually is provided in the Blackboard. You can open this file and check out the worksheet model, and the purpose is to actually understand where are the decision variables. So important part, for example, I cannot further expand that, but here this column is actually constraints related cells, and also here in the blue part is also constraints. So these are all the formulations we actually established before. So you try to check and examine, you understand all this. All this Excel form. So this is a explanation about the case. I think if you read the case text, these formulations are also presented in more details there. So also would be fun. If you think it's kind of difficult, I hope this video will help you to understand the formulations. That's very important. You read the case text or watch this video. We will directly use the formulation and the Excel file in the lecture. So we do not use extra time to explain how these formulations are constructed. That's it.